Hello and welcome to Reuters events webinar, Hydrogen Investment Strategies for Success, done in collaboration with our content partners, Johnson Matthey. I'm Vlad Ionete, Hydrogen Lead at Reuters events, and I'll be moderating this webinar. Just a bit brief of housekeeping before we begin. This webinar will last up to an hour and is being recorded. So we'll send you the full audio within a week's time. You also have the facility to ask questions to the Q&A box, and we encourage you to use it throughout the hour. We'll be running a poll throughout the webinar, and you have the option to vote, so please make the most of our interactive tools. If at any point you want to ask the panelists a question, simply enter your question into the text box, and we'll try to get it during the Q&A session. I'm joined today by our esteemed panelists in our discussion. We first have Eugene McKenna, Vice President, Hydrogen and Sustainable Technologies with Johnson Matthey.
Hi, everyone. So I'm with Johnson Matthey. We're an old company, 200 years old, with a long history in association with hydrogen. Our mission today is to catalyze the net zero energy transition. We've got a wide range of relevant technologies with a long track record behind them, in particular in blue low carbon hydrogen and components for making green hydrogen, and also for doing things with hydrogen, such as making chemicals like methanol and formaldehyde.
Thank you, Eugene. I'm also joined today by Nilay Shah, Head of Chemical Engineering with Imperial College London.
Hi, everyone. I'm Nilay Shah. I'm a chemical engineer with a lot of interest in how to make and use hydrogen.
Thanks, Nilay. And also I'm joined today by Henrik Solgaard Andersen, Vice President with Low Carbon Solutions with Equinor.
Yes, hello everybody. Henrik Andersen here. I'm heading our global hydrogen project portfolio. If you're not familiar with Equinor, that's a Norwegian-based oil and gas company transforming into a low carbon company through activities in renewables, offshore wind, solar, but not at least, which I think is the top of this event, low carbon solutions like CCS, low carbon hydrogen, green hydrogen, and we are developing quite a broad portfolio of different projects in Northwest Europe, UK, Norway, and US. Thank you.
Thank you, Henrik. Today, we've got a lot to discuss, but before we start, I just want to set the context for the hydrogen opportunity and what it takes to make this a successful project. We see that whilst clean hydrogen project pipeline has grown to $570 billion, just 7% of hydrogen projects have secured final investment decision. Today, and during the webinar, we'll discuss what strategies can be used to unlock the opportunity and secure final investment decision. But before we start, we have a poll ready for our audience, so please make sure that you do vote. Which milestone do you expect your hydrogen project to reach in the next 12 months? Concept development, technology selection, final investment decision, or construction? Please remember you have the option to vote. We also ran this poll live at our hydrogen conference last week, and we've seen that 38% of participants do expect to reach final investment decision. While you vote, we'll also play a short video from Johnson Matthey in the next few minutes.
Are you ready? I'm Syngas 1.0. I'm here to take you on a hydrogen journey with Johnson Matthey. Follow me. We're building on a past that supported the NASA Apollo missions. It informed our future. Now we help create energy. Our LCH technology has captured the imagination of the hydrogen industry, helping new projects save over 6 million tons of CO2 and rising. Our blue hydrogen technology gives 2 options instead of 1. Syngas deactivated in 3, 2, 1.
At the start of the webinar, we asked the question, which milestone do you expect your hydrogen project to reach in the next 12 months? You had the options to vote concept development, technology selection, final investment decision, or construction. We are going to keep the poll running for throughout the webinar, and we'll be discussing the results at the very end. So please remember, you do have the option to vote throughout the hour. But for now, let's dive straight into the conversation. And I'd like to start with the first theme of the webinar. As industry and governments increasingly look to hydrogen to fulfill their energy needs and decarbonization targets, what pathways address scalability and cost challenges? So, Eugene, I'd like to start with you. What are the pathways to address scalability and cost challenges in scaling up the hydrogen economy?
So I think probably the first thing to say is that some of the problems and delays that we're finding, and perhaps disappointments that we're finding in the scale up of the hydrogen economy, are disappointing, but they also reflect the complexity of the scale of the task that there is in front of us. So effectively, what we're looking to do over the next 30 years is to completely reorganize the energy infrastructure that has given us the global growth around the world, that has produced the much richer societies that we see all around the world over the last, well, since the Industrial Revolution. And that's not going to be a simple task. And if you look at the scale of infrastructure of the fossil fuel economy, we really need to make an impact, and make an impact on the same scale that we see of the fossil fuel economy that's around us. So scaling up is not going to be easy. And we also, you can also imagine that we need things to happen all at the same time. You can't build out a small piece of the infrastructure that's required for the new hydrogen economy all on its own. It's got to have an upstream and it's going to have a downstream. It's all going to have to happen at the same time. I think that's one of the reasons why the projects that are going faster are the vertically integrated ones that get folks together cooperating in a consortium that have an upstream, everything all of the way from energy, and if that's natural gas for a low carbon hydrogen project, all the way to what we're doing with the hydrogen at the end. I think in terms of scalability at the start, we have our two general types of clean hydrogen. So we have electrolytic hydrogen, which is renewables, splitting water into green hydrogen. And that's a fascinating business, which is going to be enormous very soon and well into the future. But it's got huge tasks. It's got huge hurdles to overcome in terms of industrialization and scale of production all along that supply chain. I think one of the tricks to scalability right at the start is technology that we already have in front of us that's mature, and that's the low carbon hydrogen that is being deployed many places around the UK, for example, and there's a project pipeline around the world making hydrogen from natural gas and sequestering the carbon dioxide. So I think at the start, one of the answers to scalability is to produce, is to put ourselves in a position to put in place world scale plants that are producing material amounts of clean hydrogen right at the start to kickstart that hydrogen economy, and then we can wait for and encourage the rest of the hydrogen economy to build around those first kind of lighthouse projects.
Thanks, Eugene, for your comments there. Nile, do you have anything to add?
Yeah, I think building on that, one of the challenges we have at the moment is low carbon hydrogen isn't yet a fungible commodity. And so to get to scale, unfortunately, you need to build out whole ecosystems all at the same pace. So you need to develop those robust value chains all in one go. So anybody who's developing a hydrogen project can't just think of where do my inputs come from and how much hydrogen do I make. They've really got to think about who else am I going to partner with to store hydrogen, who's going to transport hydrogen, and most importantly, who's going to use that hydrogen. And all those value chain participants, they need to act in concert. And so when it comes to things like policy support or procurement or subsidies or government actions, they have to be actions that are oriented towards the ecosystem or the value chain rather than just one player. Because if they focus only on one player in the system, the scaling and the development will be too slow. So it's very much the case, just as we heard from Eugene, that the best and the fastest projects are those vertically integrated ones, because you've got a producer, a storer, a transporter, and an end user. So you have to lift all of those up in one go. So you have to have a project focus rather than just say a technology focus. And in fact, I think, in my view, the companies that are going to be really successful are the ones that aren't trying to invent some new amazing technology, but to use the best of what's available for the components of that system and actually have really good project competence. So I think that's what we need to focus on, particularly in the next 5 years.
Thanks for that, and thanks for that, Nile. And Henrik, what are your thoughts on this?
No, I think generally, when you look at hydrogen, it has, as we all know, a huge, let's say, broad area applications and have a long track record, a fantastic legacy. Been working on hydrogen industry for decades. In fact, hydrogen started 200 years ago. Maybe people might not be aware of that. It was called town gas. We used hydrogen-rich gases when we were boiling our water in the kitchen or lightening our streets. That was hydrogen. So we in fact have done some of this before. And the industry, we are doing this. You know, in US, they have a big hydrogen network, hydrogen value chains where production, pipelines, something and storage are connected to different off-takers. I think the new challenge is we are now going out in an area where we do not have, let's say, a viable business case, right? The market doesn't exist, and we do something that are not driven automatically by market mechanisms. So we need, let's say, more government support. We need to create a new market. We need to go into new sectors that are normally not using hydrogen, and then that needs to be developed. I would say the positive thing, and there's a little bit of reflection of it done, because if you go 8 years back, nobody was really talking about hydrogen. That was some niche market. It was something people did in the transport. It was very focused on building new fuel cells, new electrolyzers, storage for cars. It was considered like a big R&D project. And I think in Equinor, we were sometimes looking and say, can't we not do a little bit more, right? This must be something that really moves the needle. And then when we looked into the legacy and history of hydrogen, we saw that, yeah, in industry, we can build big-scale hydrogen, and combined with our experience of doing large-scale CCS, we certainly can produce hydrogen in a very low carbon footprint. And then we also saw, yeah, we can, in fact, people are already using hydrogen in the industry for heaters and boilers, not just for producing ammonia or methanol, but in fact using that for energy purposes. And suddenly we saw, okay, a lot of these components exist. They're proven, they're referenced. So certainly we were playing the ball from being an R&D project, saying, yeah, the technology is here, it's reference proven. Now we need the policymakers to make the next step, to create the framework, create the regulatory, etc. And I think that is what we're seeing now, right? The UK was first, right? They captured this and they started a process in we see in the cluster sequence. Now US came in with their RAA, and now Europe is coming up with a carbon contract. So now the ball is moving, right? It's not something about technology and be ready. It's the technology is there. It's about creating a framework, scaling up, funding in infrastructure, storage, production, and supporting the emitters to, let's say, convert from, let's say, natural gas or fossil-based to cleaner solutions. So that's where we come from. And if you look at the next step, it's about the deliverability, the ability to us to deliver, right? Because it's still nice idea, nice vision. Nothing is really in operation today. So I think from Equinor, it's super important that the first projects on stream are really focused on deliverability. We need to show that these projects are working. And when we show that and we create comfort, then we can really expect more, let's say, focused on scaling up and creating a bigger scheme for this new type of market.
Nile, I'd like to come back to you and discuss more on the fact that developers are struggling to access expertise in project development and advice on technologies. How can this be this scaled up?
Yeah, I think that's a really good point. I mean, the expertise is growing, but I think I think the challenge is a lot of project developers have a high level understanding of how to develop a good hydrogen project. But then, particularly for green hydrogen, but also to some extent natural gas-based hydrogen, they then need a lot of help in, for example, the practical aspects of integrating variable renewable energy, whether you need some battery storage, how to operate, well, which electrolyzers can operate flexibly, how to operate them flexibly, what compromises might be made in doing so, how much hydrogen might you need to store if you've got some kind of service level agreements for your offtakes, how to access carbon capture and storage infrastructure if you're going for a natural gas based project. So that at the second level down, there's a lot of expertise that is required to develop an effective hydrogen project. And I'm seeing that the project developers are putting out a lot of queries, and I think that's where one thing that will be very helpful, and perhaps that's where some of these industry associations, like the various hydrogen industry associations, can start to think about what things from a technical competence can be considered pre-competitive, a bit like in the oil and gas industry they do on things like safety, for example, or in the oil and gas climate initiative on climate. Will we start to see industry associations developing best practice guides and supporting documents? In parallel, we are seeing that engineering contractors and consultants are building expertise. And of course, what we're trying to do at the university is to graduate students that have a lot more expertise and knowledge about these new emerging clean energy industries, just as in the past we used to impart a lot of knowledge which is probably relevant to the oil and gas industry. So a lot of things have to happen in parallel if we are not going to have bottlenecking of projects from a technical expertise point of view, especially in this issue of some of the very detailed aspects of implementation.
Nile, if I could just add on to that, just from the perspective of skills, I think there's a huge opportunity at the moment as we see a transition from a fossil fuel world to a renewables and clean energy world, that the transferability of the skills should be very, very good indeed. And it's a really crucial moment for the skills in the old oil and gas industries to make that transition across, rather than if we tear that down before and let those disperse, it will be much harder to build them back up again.
You're absolutely right. So in the UK alone, there are 300,000 people that have some knowledge of how to work with natural gas all across the system, from the upstream and offshore all the way through to boilers in the house. So those 300,000 people, they are there with a lot of skills in gas-related technologies, and you can see that they can make an important contribution to hydrogen.
Eugene, I'd like to come back to you, and in this context of speeding up project investment and production levels, I'd like to ask you to discuss more the impact of scale and technological innovation on cost reduction and the importance of carbon intensity in project viability.
So I think once again, thinking about new technologies, and new technologies were 8 years ago. I think we were discussing the fact that hydrogen was a twinkle in people's eyes 8 years ago, and now it suddenly got real. And there was a need for definition of what types of hydrogen we were dealing with. And we've been through the whole color thing, which we're trying to back away from now, of green hydrogen and blue hydrogen, to really focus on low carbon hydrogen and low carbon hydrogen standards. And I think if you think about what it is that we're trying to do, which is to have the chemical feedstocks and the energy carrier that we will need to decarbonize the energy and chemicals world, we want to have it without greenhouse gas emissions. And I think the carbon intensity of the processes are really important, and they're really important to future-proof the technologies that people invest in. So I think there's been moves to look at low carbon hydrogen standards in the US and in China and in Europe, and in fact the UK's got one of the strictest scales in the world, or standards in the world, for what constitutes low carbon hydrogen. So I think one way that you can think about scalability and getting a project forward and making it future proof is to make sure that you have deployed the best possible technology. I do think that in getting massive projects going at the start, that low carbon hydrogen from natural gas has a big role to play, because in some of the projects, for example, the Equinor project, the Humber in Saltend in the UK, kind of looking at 600 megawatts to begin with, and which is often 3 times bigger than some of the biggest green hydrogen projects, and with tried and tested components that are being deployed in the, for example, the methanol market around the world. So you can make sure that you're making the most hydrogen you possibly can from your methane, that you're capturing the maximum amount of carbon dioxide, that you've got the cleanest natural gas in the world, and you've really thought about that all of the way from producing natural gas through to producing the cleanest hydrogen. And I think that's really a way of ensuring that you've got the lowest cost from a CapEx and OpEx perspective to give your project the best chance of having the lowest levelized cost of hydrogen, therefore the best chance of success. I think that's not everything. We still need help in, as this is still more expensive than just, doing steam methane reforming and letting the carbon dioxide escape. We still need to help this industry at the start with subsidies, and we need a regulatory framework that will enable it to compete on an even footing with polluting alternatives, which I guess that also implies that those need to be taxed as well in order to put us on a level playing ground. So I think that's low carbon hydrogen, the blue hydrogen, if you like, and it's really important people think about deploying the best technology. From a green hydrogen perspective, from electrolytic hydrogen perspective, the route through to lower cost projects has to be a constant deployment over the next 10 years. I think just at the moment, there's a little bit of waiting for people anticipate that costs will drop with volume of electrolyzer production over the next 10 years. And if everybody waits, the costs won't drop. So I think kind of legislation and government regulatory frameworks really need to make sure that we have a steady deployment of electrolyzers over that time, scaling up, rather than hoping that we can wait for it to be cheap in the future and deploy it when it's cheap, because that simply won't work and won't happen.
Can I just add a little bit to the carbon intensity discussion, because I think that's a super important topic when it comes to low carbon hydrogen. And in Equinor, we have somehow landed on the ATR technology, which I think is very well known for Johnson Matthey, and we are using your technology in many of our projects, and it gives us super high capture rates, 95% or even above. What we need is also we need to import a lot of power, because it needs that to run the air separation unit. So also power, grid power intensity is very important, and the regulation around that. And then of course the natural gas supply is super important. And what we're working on Equinor is, of course, reducing our oxygen emission. We have some of the lowest in the industry, particularly on natural gas, and we are working quite intensely to develop a concept where in fact can more or less get gas directly from the field, and we can show it through blockchains. Some of our best gas fields have so low emissions that we in fact can reach total carbon footprint which are below 0.45. That's classified for $3 per kilo if it was been in the US. So it just illustrates the importance of let's say carbon intensity and what you can achieve with when you're sourcing the right gas and the right power for these now super efficient capture plants, ATR plants, that companies like JM is developing. So it's just a little bit of additional information here.
Yeah, I do think it's really important, because looking forward around the world at the major resource holders who have natural gas capability, looking forward, there's only really a few possibilities for what happens to that gas. It either gets burned and the carbon dioxide is emitted, or it stays in the ground, or it turns into the very best low carbon hydrogen. And I think it's very difficult to ask many of the countries with these resources to let that resource stay in the ground. And I think kind of human nature tells us a lot of it's likely to come out of the ground. So I do think turning it into clean fuel is a fantastic option. And then making sure that whenever we do it right, as we do when we get the very best gas and use the very highest capture rates, as we do for example in the Saltend project, that gets to be recognized, and it's not competing with projects that don't have as high capture rates and have a lot of fugitive emissions in the gas supply chain.
I'd like to stay here in the the debate of blue hydrogen, green hydrogen, and Henrik, I'd like to come back to you and ask you to talk a little bit more about the potential for both blue hydrogen and green hydrogen to play a role in the energy transition. Have you got any thoughts on this?
Yes, a lot of thoughts, and it's a very interesting topic in general. You see how it changes from country to country, from region to region. Like in the UK, it's a very agnostic approach. It is almost categorized as low carbon hydrogen. We don't talk about blue and green. A little bit same in the US, whereas in Europe it's very much blue versus green, and more like a battle. My view and Equinor's view is that we need both, but they will probably develop at different pace, the different timing and different scale, and that can even change from region to region. But we see particularly, let's say, in Europe, and for that matter, in maybe also in the US, where you have a big focus on industry that needs a lot of, let's say, call it base load hydrogen, and maybe also integration with the hydrogen facility itself. A low carbon hydrogen facility have, I would say, more to offer, right? And that's why we use it in industry today. That's the reason, because it's integrated very well with industrial processes. It's more than hydrogen, it's steam, it's utilities, is industrial gases. Everything can be packed together in a much more cost-efficient way. So basically, we see hydrogen not only as a very strong starting point for the hydrogen economy due to these, let's say, benefits on synergies to the industry, but also due to the cost and scalability. And that gives green hydrogen a little bit more time to develop. There are some challenges in green hydrogen. We have learned that the last years, right? Scaling up, making the technology really work on industrial level to the industrial requirements about reliability. Reliability is everything, right? If things stops, it has big consequences for the economy of a project. That is super important. But we also believe when that is in place, we will also see some kind of a shift as it develops. When we get more, call it clean electron, which is fundamental for green hydrogen, right? And that's what we are lacking also as an add-on, right? Technology issue, but also the access to clean electrons, particularly in Europe, where many of these electrons will mainly be used to decarbonize the electricity sector before we use hydrogen. So there will be phases going through, but when that happens, it is clear green hydrogen will have a similar role as renewable electricity have today, right? It will be very cheap at a certain point where the wind is blowing a lot and the solar, and then we cannot compete with low carbon hydrogen. Then green hydrogen will be cheaper, and maybe we'll see where we somehow start to see the balance is shifting a little bit, and low carbon needs to, let's say, adjust to this new kind of market environment. A little bit the same as gas turbines are doing today in the electricity sector, right? They are adjusting to the market. They know they cannot compete with offshore wind and solar wind when the wind is blowing, the sun is shining. They have to run down their facility. Maybe we'll see the same in blue hydrogen. That's why we're also very interested in blue hydrogen or low carbon hydrogen that are also flexible, that can run up and down. But we know with the HCR channel, we can ramp it up and down. That means we can adjust the capacity to the new market situation when green is coming. And I think that's a nice way of creating synergies between blue and green. But I think in the early phase, in developing the market, low carbon hydrogen will be the driving force to make it happen. And We see that in UK, right? The biggest project are low carbon. We see that in US. Europe is starting to let's understand that they need that. They are more like they want green. They don't want to be dependent on fossil in the long term. So they have this, let's say, challenge about being more or less dependent on fossil in the future. So they have to balance that. But generally, they see that they also need low carbon hydrogen to really kick off, call it the hydrogen economy, and pave the way for green hydrogen. Thank you.
Eugene, Henrik mentioned potentially regional preferences for blue versus green hydrogen. I wonder if you have any thoughts on that.
Yeah, I think geography will play a big part in choice and what technology is best for particular regions. And I think this will be very exciting over the next few decades, seeing a new energy infrastructure arise. I do think, low carbon, blue hydrogen, and green hydrogen should compete, but compete in a friendly competition, if you like. I think at the moment, for example, we see that natural gas prices set the cost of electricity in countries like the UK. I can imagine a situation in the future where green hydrogen sets the price of gas instead of and flips the whole thing around completely, and the green hydrogen gets cheaper and cheaper to the point where it's only the very cheapest gas that can come out of the ground to make blue hydrogen long time in the future. But just as things stand at the moment, it's quite clear that in some parts of the world it's windy and very sunny, and often in the very best locations it's windy at night and sunny during the day, so that you can load electrolyzers to the maximum possible around 24 hours. And those will be the cheapest places to make green electrons. Often they are far away from where we want to use that energy, and hydrogen will become that green electrolytic hydrogen will become a great way to transfer that energy through space and time to where we want it and how we want to use it, as energy or as a chemical feedstock, which will also involve us in finding interesting carriers. Will we carry that via liquefied hydrogen, or will we make ammonia that we crack back into hydrogen at our destinations, or methanol as the carrier? So I think all of those are interesting technology areas that will clearly make places like Australia great places for making green hydrogen and green ammonia and green methanol. On the other hand, there are other parts of the world, and for example, the UK, which is blessed with fantastic geology and Norway for sequestering carbon dioxide, and also have natural gas resources. So that makes those very favored locations for making low carbon blue hydrogen. At the moment, it's also very windy in the North Sea. It should say so. That kind of whole North Sea region, there's a certain circularity, having been a kind of cradle of enormous sources of fossil fuels. It should also now be exactly the place that fosters both a low carbon blue hydrogen ecosystem and a green hydrogen ecosystem eventually, because of playing to that to those geologies. So I think anytime anybody talks about a price and a global preference between those two, it's missing that complexity of the geology. And once again, the United States ends up blessed with both the natural resources for renewables, for making green hydrogen, and also wonderful geology for sequestering carbon dioxide. I think if you look at the amount of hydrogen that is required to get to where we want to go, and the part that we hope hydrogen will play in the decarbonized net zero world of 2050, it's a similar amount of hydrogen to want energy to move about that we're looking at in the LNG market of today. So if we look at the infrastructure that's required, that's what we're looking at. We're looking at energy being produced and moved around the world, either as liquid hydrogen or as ammonia, or carbon dioxide moving around the world. It'd be either sequestered where it's produced, or it will be moved to favorable locations where it can be sequestered. We've done this before. The trick is, if we look at LNG, it took 30 or 40 years to move from really like a pipeline. You needed to make some liquefied natural gas, and you needed to have a plan for where you were going to regasify it. It's still moving towards an area where that's a completely fungible liquid market in in moving LNG about. And we could see how quickly and with the agility that moved, at the onset of the cutting off of Russian gas, pipeline gas to Europe, how it surprised everybody how agile that ecosystem was in supplying energy to Europe and to elsewhere. So it's a long way for hydrogen to go, but that's where it's got to get to based on playing to the best strength of people for where it should be produced and recognizing we're going to have to move that energy around the world.
Thanks for that, Eugene. And Nile, I'd like to actually come back to a point you made earlier about skill sets and technical capabilities to developing blue or green hydrogen projects. Are there any difference in skill set or technical capabilities in working on green or blue hydrogen projects?
To some extent, yes. I think particularly in understanding the technology. So, blue is a classical process technology. You scale volumetrically. You get a lot of benefits from going large, and you really do need to understand issues like CO2 compression, storage, and sequestration. Green, you to some extent will need understanding around electrochemistry, around water purity and water purification, and then the fact that you scale through area rather than volume. So you need to think about how to design a modular system and how to have the right balance of, maybe small, medium, and large modules that you run in different ways. So you need to understand a bit more about operational control, because you will, in whichever geography you are, need to do some time matching between your renewable energy supply and your electrolyzer operation. So there's a lot of systems engineering in both, but one is more, there's more sort of process engineering capability in one and more electrochemical engineering in the other.
Thanks for this, Nile. And we've discussed a little bit about the opportunity and some of the technical capabilities needed to scale up the hydrogen economy. But I'd now like to move to some of the threats that exist at this point in time to reaching a stable hydrogen economy. And Nile, I'd like to stay with you and ask, what do you see as the biggest threats for the global scale up of the hydrogen economy?
So for me, the biggest threat, or the biggest factor that is going to slow down the uptake, is the lack of policies that are incentivizing and supporting the use and demand of hydrogen. So when I look at a lot of the potential projects that you see mushrooming around the world, what's stopping them from passing through FID and going into construction is actually having secure offtake. Because what these projects are tending to look for is not very much in the way of spot exposure, because there isn't really a proper hydrogen commodity market. So they need to have a high, by that I mean maybe 90+% offtake, and that offtake needs to be quite secure. So it has to be a strong kind of offtake agreement. And so the counterparty doesn't really exist at the same scale. So there's a lot of ambition to produce hydrogen. We don't have yet the matching ambition today to use hydrogen. And so a lot of policy development needs to focus on that, in my view.
Can I add a little bit to this topic? Because I think this is probably quite important in these days, and probably also impacts the answers for the first question you had on where do you see progress, right? And I think the general trend is there are many projects, but many are struggling with getting to an FID. I think that's the general trend. I think people are maybe forgetting a little bit, but it's not many years since we had COVID, right? And it cost a lot of money. And like in Europe, they had to go and borrow a lot of money. And now we are in the phase where we need to do the economy recovery after COVID. And I guess that is for all countries. So a lot of money is now going to be spent to pay down debts on the COVID. Then in Europe, particularly, there's Ukraine war and the associated gas crisis. And that followed then with the inflation and cost escalation. I'm not sure if people are aware, but it's quite amazing. If you take IRA as an example, when it was $50 per ton, people were saying, oh, nothing will really happen, right? And then there's talk about now we'll increase to $85, and everybody's saying, oh, that will unlock so much CCS. That was 3 or 4 years ago. Today, $85 is not enough. With the price escalation, I think you're talking about 100, 150, maybe even more to make that equal 85 3 or 4 years ago, right? And the same you see in Europe and other prices going up. And I think that's the biggest threat at the moment. And also that the government needs to, as I mentioned, they have to pay down the COVID debt. In Europe, it'll be NATO budgets, right? We need to meet the 2%. Some of these are costing money. And also we see this on the political side, politics opinion can change. These are the biggest threats for hydrogen, right? We are still in the infant phase where the market where we need a lot of support and also a lot of money to fund this. So I think that's very important that we have that back in our mind when we're developing projects, that we are trying also to find good solutions with government to see how can we fund this in a social responsible way. So I think that just to add to this major threat for us. Back in 2008 before COVID, I think things were looking very well. I think COVID had delayed a lot on not only hydrogen, but general and low carbon due to these external circumstances. We need to accept that. But project developers need to be aware that it's not a walk in the park, as it might have felt like back 3 or 4 years ago. It's much more an uphill for the moment.
Henrik, just if I add to that, just it feels a little bit like at times that great initiatives, often by quite agile government regulators, have facilitated the development of projects. And perhaps these have developed surprisingly quick for the regulators, and the projects have all run up to FID. But there's a whole bunch of new regulation that's required to make sure that positive FID makes sense at this point, and that's where we need to catch up. I think.
Yeah, there are still regulations that are, let's say, lagging behind, right? As in Europe, we don't have any standards on low carbon hydrogen. There is a plan that this will be solved. We need a certification scheme. We have the RED III, which are very, let's say, creates a lot of uncertainties because it talks about the ratio between green hydrogen or RFNBO hydrogen and low carbon hydrogen, which are natural gas based, nuclear based, all non-renewable. How that is, what will be accepted post 2035. So there are areas where there's still a lot of uncertainties that needs to be solved. Saying that, I think there are general good progress, like UK had their cluster units, now Germany launched their carbon contract for difference. The mid double digits, that means 50 billion euro, not only for hydrogen, but also CCS, electrification, everything that contributes to carbon reduction. You have the IRA in US, and Japan now also announced the $20 billion for starting a hydrogen. So good development, right? But we need to accept there will be challenging moving forward because there are other things that also needs to be funded by these governments, and it's still political and uncertain area we are entering into.
We've covered technology, we've covered regulation, but I'd also like to ask the question of infrastructure. What role does infrastructure play here? And is this a threat to developing a stable hydrogen economy? Henrik, maybe perhaps start with you.
Yeah, of course, we need to connect production with the offtake. And in most cases, unless it's really a side-by-side where we have production next to the key offtakers, we need infrastructure. That's almost like a no-brainer in many aspects. In Solvent, we were so fortunate that we built the plant next to all our offtakers, so it's just some short distances. But when we are beyond that point, when you really want to scale up, we need to go out to, let's say, a bigger market. We need the pipelines. That's so simple. In some areas in Europe, we are so fortunate that, in fact, they have a dual system, because the natural gas system in North Europe was based on what is called the Groningen gas field that was developed 4 decades ago, which is a field with, let's say, low calorific value. So the pipelines, then the Norwegian gas came in and Russian with high calorific value, and they had to establish a parallel system. Now the Groningen gas field is, let's say, shutting down. These low calorific pipeline is now available or redundant. So a lot of the hydrogen pipeline development in Europe, North Europe, is developed by repurposing these low calorific value pipelines. Of course, some areas you need some add-ons, but it gives a much, let's say, smaller, let's say, barrier to overcome to develop these infrastructure. And in general, in Europe, the TSO are very proactive. They are very forward-leading. In Holland, you have Gasunie, who developed the Dutch backbone with aggressive plans in 26, 27. The CorNet in Germany was announced, I think it was late last year. Now all the TSO needs to provide their plans in May, June for their CorNet will have an implementation phase from 26 up to maybe 2037, but it will be 9,000 to 10,000 kilometers of hydrogen pipeline. And similar in Belgium and France, you have Fluxys and the French TSO working on their pipeline. So a lot of positive. UK is lagging a little bit behind, I would say. It's still in the conceptual phase. And that's also the reason why in Equinor now we have started an initiative in the north bank of Humber around the Saltend to develop we call it an industrial network that, let's say, links Saltend project will store its north of Saltend, 20, 30 kilometers, and Easington. So a little bit network of 20, 30 kilometers apart, but it's something that just keep us growing a little bit so we're not just, let's say, locked into one site. I'm not familiar how they're doing in US. It's more, let's say, on private initiatives. I think a lot of the US projects are still very local oriented and not really based on a huge, let's say, backbone infrastructure. So very much focused on around the US Gulf, where you in fact have some hydrogen network. It's also very focused on around ammonia, of course, as a way of let's say, exporting to Japan and Europe. But that's a general situation. I think we need that. We need those pipes to really scale up and expand. I think that's clear to everyone.
Aware of time, so I'd like to move to the final point of the conversation before we have time to discuss some of the questions from the attendees. We see the opportunity, we see some of the risks, some of the threats, some of the solutions. The question here is this a collaborative approach or a competitive approach? What is the way forward to develop a hydrogen economy? Collaboration or competition? Nile, I'd like to start with you.
Well, I think first of all, there's always going to be a competition in the sense that some of the early developers are looking to gain some advantage. But having said that, again, you'll quickly find that the development of the whole hydrogen economy will stall if it's too much of a competitive system, because the whole system has to work effectively from end to end. And so you definitely will need to see that at least from the different elements of the value chain, you won't be able to take a fully adversarial approach. For example, trying to get the best price for something or to push down cost for someone else, but actually to look at it as a system that needs to be functioning effectively, and therefore sharing value fairly across the system is the only way you can guarantee that each element of the system is going to function effectively. So I would see you almost see big value chains might compete against each other, but within the value chain you definitely need a good amount of collaboration to get the economy up and running.
Eugene, collaboration or competition?
Well, I'm always naturally, as a technology provider, we'll have a preference for collaboration, because the best projects happen when you get the right group of people together collaborating on a project to get you the best possible project. I think at the end of the day, in developing this market, we need the right combination of collaboration and competition. So we need to get the best partners together for individual projects, then projects compete with each other. And I think there are certain parts of the value chain at the moment that will need encouraged by regulation and government to get players in to collaborate to make sure they get built out, particularly in infrastructure. I mean, we don't some aspects of infrastructure will be natural monopolies that need regulated. So we don't need a bunch of competing pipeline networks in small countries when clearly we should put our effort into one. But right at the moment, at this stage in the development of the hydrogen economy, the projects that move quickest are the ones that put a bunch of partners together who are going to go all of the way from the upstream to the downstream, from the raw materials to producing the hydrogen to working out what you're going to do with it and consuming it, and getting those people working not adversarially together, but working together collaboratively to produce the best possible projects. They produce the strongest initial hydrogen projects that will create a good platform for those collaborating partners to replicate that and scale that across markets.
Maybe I can add a little bit experience from our projects we have it in Norway, UK, and Europe. So if you take Norway, we had the Longship project, which now you see a background is Northern Lights. It's the CO2 receiving facility that we are 98% completed. That can, let's say, receive 1.5 million. Can easily be scaled to 5 million ton if when we take the FID on the phase 2. That is connected to Norwegian capture plants and even capture plants in Europe. You can say initially the state took the architect role and ensured the value chain were handled in a good way. That you can do for small projects. In UK, you can say it was a little bit different. We started like, well, let's collaborate, let's go together and start. And we worked very well. And then UK got started the cluster sequencing and talk about competition law, NDAs, blah, blah, blah. And then suddenly we had to shut down and we couldn't talk to anyone. We just need to fulfill these requirements. That's also the rule of the game. So we went for being a nice family to be competitors and we couldn't talk. And that's a little bit how it is. In Germany or in Europe, you can say it's going to, let's say, a system where the emitters get the funding and they buy hydrogen over the fence like natural gas today. And here again, there are quite strict processes. So ThyssenKrupp launched their hydrogen tendering process earlier this year. It's based on complete the same, let's say, setup as natural gas with, let's say, Chinese walls, a very strict way of working with the suppliers. So not very big room for collaboration and bilateral discussion. It has to follow certain regulations. So there are different ways. Collaboration seems nice in the beginning, but it always ends up in being a competition and we have to follow competition laws, etc., etc. So I think that's just the name of the game. And we usually adjust to that. Doesn't end up to being a big issue. But we need to have some kind of trust, right? Because it's difficult to have firm agreements before you add FID, and up to that point, you really need to trust all actors in the value chain. And I think that's a little bit the new elements that are probably not the case for established markets.
Thank you for these. We'll now be moving into audience questions, and we've got a few already in the chat. I'd like to start with a question from Dirk. What are the main hydrogen users? In mobility, is road transportation a viable end use? Is aviation and marine a better use for mobility? Or is the industry a more viable solution? Henrik, any thoughts on that?
It's probably depends on the different regions. So if you take Germany example, the key focus for hydrogen in Germany is really industry, right? And particularly they have put steel in the forefront. They want to use the steel sector to drive the hydrogen economy. So they already provided state aid to replace their blast furnaces to DRI, which they can then be retrofitted to use hydrogen later. So they are more or less trying to, let's say, guide the direction. And steel is in that case the main driver. In UK, they don't have a lot of steel. It's different. They have a small industry. I think in UK, hydrogen will be more focused on power, I think. Maybe heat, even though I know it's very debatable in UK whether it will be hydrogen or heat pumps. But also here it can be transported. I think in Norway, particularly, which are very, let's say, strong on maritime will be a huge, let's say, driver for the hydrogen economy. So I think all countries can have different perspective based on their industry and where they see here they need to focus from competitive reasons for where they can really develop new business industry. So it's very diverse. There's no like one single answer. I think that's a little bit the thing we need to have to understand the exact, let's say, what drives different countries' hydrogen needs. It's, as I said, it did change from country to country.
Could I have a little add a little bit onto that question too, because I think there are some transport solutions, in particular heavy-duty transport solutions, where battery electric vehicles really don't look like the solution, because if you're pulling a large payload, you don't want a really, really large battery that's in there as well. So fuel cells are the leading candidate for replacing heavy-duty transport. And I think there is quite a difference across Europe and the UK on how well that's being rolled out. So it's been quite well supported in Europe with mandated refueling infrastructure. Not in the UK, where there isn't any mandate at the moment. So it's going quickest in China. There's a pathway in Europe, and the UK has to catch up a bit. But it's actually quite important from the perspective of use of critical raw materials, because the platinum that is currently going into internal combustion engine systems for catalytic converters, that needs to find a home in fuel cells to keep the mines open, and the mines need to be open in order to produce the iridium that will produce the electrolytic hydrogen. So I think there's that kind of synergy between green hydrogen production and the application of, and the transport application of fuel cells. Of course, it's a stationary application for fuel cells as well, but and definitely at times it's the best application for aviation as well. Hydrogen is one of the only, clearly hydrogen can produce sustainable aviation fuel, which is kerosene as well. People are also looking very closely at hydrogen for aviation, where it truly decarbonizes a really hard to get at application. And I think carbon emissions from flying at altitude come not just from the carbon dioxide, but from the nitrogen oxides that are emitted by burning kerosene, and the water vapor that's emitted at high altitudes. And this is where hydrogen would really help decarbonize aviation.
Thanks for that. An interesting question from Faith. We are seeing, are you seeing any trends in public sentiment regarding hydrogen projects? Nilay, any comments on this?
I would say that there's still a lot of caution around it coming into the House. So I think the sentiment there, I wouldn't say, looking at least in the UK, this recent red car trial, is particularly positive. I would say, though, that people see it as an exciting thing for sectors where it's managed in an industrial process and it's part of an ability to decarbonize. So again, that's some of the big commodities like iron and steel, and of course the marine fuels, which is incredibly difficult to decarbonize, aviation fuels, long distance rail as well, either directly or in the form of an e-diesel. So I think these kind of areas, people see it as very promising, because they can sort of see that it's a way of effectively decarbonizing sectors that can't be electrified. But I'd say there's probably still a lot more caution about something new coming into the House. It's interesting because in some ways perceptions have changed. When there was a switch from town gas to natural gas, which of course involves a big change in appliances and so on, it seemed to have been at a time when there was probably a lot more trust in public institutions and industry.
Thanks for that, Nilay. And aware of time, we're coming to the end of the webinar. But before we do end, I want to discuss through the results of the poll that we did ask at the start. Which milestone do you expect your hydrogen project to reach in the next 12 months? There were 4 options available: concept development, technology selection, final investment decision, and construction. We can see that most participants from the webinar have voted 46% concept development, with 25% looking at technology selection for the next steps in their hydrogen projects in the next 12 months. I'd like to put the question to the panelists. Any comments or thoughts on the results? Is the next step in developing hydrogen project at the concept selection?
At least I can talk from Ecuador. I think I would also say the majority of our projects are at concept, except the one behind me. We took an FID, I think that was before or right under COVID, so it was a different time. there's, as I mentioned, a lot of uncertainties. We are pushing some projects. So we took, in fact, what we call the decision gate 2. Our executive board took the decision to move into feed our H2M Eemshaven project in the Netherlands, which is, in fact, Equinor's first in our entire history for a 1 gigawatt blue hydrogen project. So there's a belief we do this, but there's, of course, a lot of uncertainties. A lot of things need to fall in places, right? And there are a lot of, let's say, open ends that need to be closed. But I think it's a bet we take. We need to push for this, but the outcome is still very uncertain. So I think there's a big risk that also next year we will see the majority will be in the, let's say, feasibility to concept phase, right? Because of all the political uncertainties.
Eugene, any comments?
Yes, I think that it's definitely the case that as much as engineering with materials, we need to do some human engineering around getting the regulation in place to help us progress the great work that's gone into developing the hydrogen projects that we have. And maybe also being a little bit less, I guess, worried about cost versus carbon and dioxide emitting available technologies. I noticed a few weeks ago, great new AI chip company, NVIDIA, had new results, and their market cap went up by $280 billion in a single day, which was more than the combined profitability of all of the publicly quoted oil companies over the previous 2 years. So when we value things, we can have it and we can pay for it. And what's at stake here is decarbonizing the energy system of the world, and it is possible with some ingenuity.
And Nile, final comments?
I think for in relation to that question, again, my personal experience of projects is I have another hat, which is a director of an e-fuels company. So for us, we know what the concept is and we know roughly the scale. We're trying to find the very best sites for hydrogen related projects, because the best possible site and technology has a lot of factors, like what's the cost and availability of electricity, is the off-taker nearby, is the government supportive, what are the planning consents like, is there a brownfield site that's available, what are the safety and regulatory restrictions around storing large amounts of hydrogen. So I think in going from the concept to the technology selection, you get involved in a lot of multi-factor criteria, which you need then to feed into your site selection and your project design. So in the projects I'm involved in, we're at that stage. We've passed concept, but to go from concept to technology, you suddenly get involved in a lot of complex decisions. Hence my original point about the need for really good expertise, people who know about environmental impact, planning, technology, operation. We need those project skills to scale up very quickly.
Thank you for that, Nile. And I'm afraid that's all that we do have time for today. Thank you to our audience for joining us on today's webinar, Hydrogen Investment Strategies for Success. Stay tuned on our Reuters Events Renewables for more content on hydrogen. And thank you to our speakers today for a great contribution. Thank you very much.
Thank you.
Thank you.